Hey, this is Professor Perez from Saddleback College. Today, we're going to find the area of some figures. And of course, we cannot get started without our student of the semester, and that's Charlie. I think this is his favorite subject. Let's see what he's up to. Hey, Charlie, you ready to go? We're doing your favorite subject. It's finding area. Oh, yeah, he likes these, doesn't he? All right, Charlie, quit fooling around. Here we go, right here. Here's our first figure right here. Okay, Charlie. Here's our figure. That was 5 centimeters, 10 centimeters, 1 centimeter, and that's 6 centimeters, and those two side lengths are missing. Now, this figure is the same one in the perimeter video. So to find those missing side lengths, you have to go back to the perimeter video to get a detailed explanation. For now, we're just going to say that each of them were found to be 4 and 4. So go back to that perimeter video and watch it before you watch this one. All right, Charlie, here we go. We have our shape, we're going to find the area. So let's take our shape and let's center it right here, nice and big for you. And we're going to break it up into 2 separate rectangles. Now, some people like to take the approach where they build this big rectangle and then they subtract a littler one from it to do this. Yeah, that will work fine on this particular figure, which is relatively simple. But we want to learn how to break up these shapes into separate rectangles, because later on the semester, the figures will get a little bit more complicated, and you're going to separate them into pieces where you'll have a rectangle here, a semicircle here, and a triangle over here. So our goal is to learn how to separate this into rectangles. So the way I'm going to do this, Charlie, is I'm going to cut this right there. And I'm going to make 2 rectangles. This is rectangle 1, and that's rectangle 2. Now, the dimensions for rectangle 1, it's 5 high and 4 across. So I don't need that 4 over there. My dimensions for rectangle 1 are 5 by 4. And for rectangle 2, Charlie, I can see that rectangle 2 is 6 centimeters long and 1 centimeter in its width. And so we don't need that 10. That 10 went all the way across. We don't need that. Now what I'm going to do, Charlie, is separate these rectangles for you. So here we go. Watch them. There they go. Ooh. Separated. Now we have 2 rectangles, and all we got to do is find the area of each individual rectangle and then sum them up to get our final answer. Here we go, Charlie. What's the formula for area for a rectangle? Length times width. Length times width, that's right. So area 1 will be length times width, or base times height, depending on how you were taught. And so our dimensions are 4 centimeters by 5 centimeters. Okay? So we'll put 4 centimeters times 5 centimeters. Remember, by the commutative property, 4 times 5 is the same as 5 times 4. So you can put it in any order you want. Okay, now, what's 4 times 5, Charlie? 20. 20. Now, don't forget, you have dimensions here. And we have centimeters times centimeters. So some people like to think of it as, okay, centimeters times centimeters is centimeters with an exponent, a 2. And that's how it's written. It's centimeters with a little exponent 2. But that means centimeters squared. Dimensions for area are always something squared. Since our side lengths were given in centimeters, it's centimeters squared. If our side lengths were given in inches, it would be inches squared. If your side lengths were in feet, it would be feet squared. But since we're given centimeters, our dimensions are centimeters squared. So the area of this rectangle is 20 centimeters squared, okay? Now, let's go to rectangle 2. Area 2 is 6 centimeters times 1 centimeter, or 1 centimeter times 6 centimeters. Okay, what's 6 times 1, Charlie? 6. 6. And how do you write centimeters times centimeters? Centimeters squared, that's right. And so to get our total area, we're going to sum up area 1 and area 2. So area 1 plus area 2 is 20 plus 6 centimeters squared, which gives us 26 centimeters squared. And there's our answer there. 26 centimeters squared. Very nice there, Charlie. All right. Now let's go to a more complicated problem. Now, don't get scared. Here it comes, Charlie. There you go. Oh, you like that one too, huh? All right. Don't worry. We'll just work at it, and it'll be really easy. Watch. We're going to break it up into rectangles. Now notice there are 2 missing side lengths. And again, this figure was used in the perimeter video. So to find those missing lengths, side lengths, go back to the perimeter video. But this one was found to be 5 inches, and that one was found to be 14 inches. Notice our dimensions are given in inches, so since we're finding area, our dimensions will be inches squared. All right. So let's center this for you, John. Let's put it over here so you can see it, really big, and we're going to break it up into pieces. Watch. We're going to make a cut up here and then a cut down here. And I'm going to call that top rectangle 1, this one down here 2, and this one over here 3. Very nice there. Okay. Now, my top rectangle, Charlie, how long is it? 17. 17, and how wide is it? 4. 4. So that 14 I don't need right there. Rectangle 1, length 17, width 4 inches. Now, rectangle 2 over here. How tall is rectangle 2, Charlie? 5. It's that 5 inches. Now, that 11 inches runs all the way up and down. We don't need that. But we do have to find out how wide that is. And to find that width, you should go back to the perimeter video, right? If you're having problems finding it, it is 3 inches. Well, from here, notice the whole bottom length here is 10, and that one's 7. So that length right there should be 3. That's 3 inches. That's how we found it in the perimeter video. And so that takes care of the dimensions for rectangle 2. Now, rectangle 3. How long is rectangle 3, Charlie? 10. It's 10, and its width is 2. So that 7 we don't need. This is the way I broke it up. And so we have 3 separate rectangles, Charlie. Now, hold on. We're going to separate it again. Here we go.
Ooh.
Right. Quit fooling around over there, Charlie. This is serious stuff here. All right. Okay. Let's find the area of each individual rectangle now. Remember, what's the formula for area, Charlie? Length times width. Length times width. So for rectangle 1, the area is 17 inches times 4 inches. Now, 17 times 4. Remember, we don't use calculators in the first half of this class, so you better not be using a calculator, right? You don't want to become one of those calculator kids, do you? No. We want to not use a calculator for the first half. The second half, when we get to the more complicated problems, we will be using a calculator. Now, you can use a calculator now to check your answers, but let's talk about 17 times 4. Let's try to visualize this and try some kung fu. Watch. Okay, here we go. Visualize in our mind. We have 17 times 4, right? That's what we have there, 17 times 4. Now, think of the 17 in the expanded form, meaning 17 is 10 plus 7. And we're multiplying 10 plus 7 times 4. So each, the 10 and the 7, have to be distributed to the 4, right? It's a distributive property. So what's 10 times 4, Charlie? 40. 40. What's 7 times 4? 28. 28. And what's 40 plus 28? 68. 68. That is 17 times 4. So that is one approach. Okay, rectangle 2. Its area is just 3 inches times 5 inches, or 5 inches times 3 inches by the commutative property for multiplication. And we get 15 inches squared. Don't forget your dimensions. Now, rectangle 3, Charlie, that's 10 inches times 2 inches, which should be easy. That's what? 20 inches squared. And now, to find the total area, we have to sum up these individual areas. So our area total, we have to take 68 plus 15 plus 20. And you can add those in any order. Well, one approach would be 15 plus 20 is what, Charlie? 15 plus 20? 35. 35 inches squared, and adding that to 68. So think about this. 68 plus 35. Well, 60 and 30 is 90, and 8 and 5 is 13, and so 90 and 13 is 103. Again, that's one approach. Or you can just write them in a column and just do it, right? Add all the numbers up, get your answer. It should be 103 inches squared. Don't forget its area, so the dimensions, it has 2 dimensions, it's 103 inches squared. Anyway, it's a tough problem there. Anyway, we got through it. We'll see you all again soon.